All right, hello. Good morning, everyone. Hope you're doing well today. What questions can I answer for you today? I didn't come here with any particular agenda in mind, things to talk about. It's up to you to ask some questions. Could there be a brief recap on DC Exercise 4 and Exercise 5? I did not pick up some ideas. We'll get to the DW mini project eventually, but that's probably going to be in a couple weeks so that people have time to read and do the material, and we will talk about the PW mini project before we get to the DW mini project. VC, so the VC mini project. Will all come in good time, but and I'm going to wait to start talking about the PW mini project until next week. So run all. So question for distance. So my distance function, so here is my class, here's exercise 4. So we want the distance right here between the 2 points. So this is the normal Euclidean distance, right? Difference in x coordinates squared plus difference in y coordinates squared. Sum of those, take the square root. We could use a square root function from the math package. I could also use an exponent of 1/2. This is my distance function that I defined here. And again, for the purposes of this exercise, you don't need this if to check. You just assume, you could just assume that this other argument is a point if you wanted to do so for the purposes of this exercise. Just make sure that you get your parentheses all in the correct locations, right? I want the difference in the x coordinates, and I want to square that difference. And the difference in the y coordinates, and I want to square that difference. I want to sum those together, and then I want to take the square root of that entire sum. Hello David, hello Kapitan, hello Nuwan, hello Suleiman, hello Canorio. I like that name, cool name, Canorio. I've not heard it before. Hello Martha, hello Raymond, hello Daniel, hello Kishan. I'm doing all right. Thank you for asking. It's Thursday. This has been a long week for me. This is a long week. I've nearly made it to the end. Hello Vasily. is what's unclear about this distance function right here. Right, this is how I use this distance function. Or here's one way I could use this distance function. Have a point call the distance method and provide the other point as an argument. Similarly, like other things, I could call the distance function in this fashion and supply both arguments in this way. Right, this function call is equivalent to this function call. Hello Ephraim, hello Francis. So this distance function right here, right, and I put in a couple of obvious points for which I know the distance here, right? This is the square root of 2. So 1 minus 0 squared is 1, 0 minus 1 is minus 1 squared is 1, 1 plus 1 is 2, the distance is the square root of 2. And this is the square root of 2 right here. Similarly, right, I mean, a few values I could easily verify. Exercise 5. The order in this compute results function right here is important. For example, I want to save this old set of points before I call the update method on my 2 clusters. So I want to save this before I update the clusters. The updating here, clearing out the points in each cluster. Hello, Somi. So the clustering right here, again, it's this iterative procedure. And we're just implementing this iterative procedure here. Sorry, Captain. I saw, yeah, if you completed IP and BC, you're on track. I mean, yes. I'm assuming you've already completed the Ion Mini project, well, then you've done 3 out of the 5 mini projects. So remember, our cluster is keeping track of the points which are contained in the cluster. So we have an initial starting point for the center. We will set that center equal to an instance of this point class because we want to use the distance function that we've defined. The add point method just does exactly what you think it should do. Just take a point and add it to this list of points by calling the append method. you could have in your collection of points you are clustering, you could have duplicates. That's fine, that's okay, that's allowable. Someone on the question board is doing some sort of check. If this point is not in this set of points, append it. Don't do that, just append it. Just append this point. Don't check, is it in there already, because duplicates are possible. The update method of the cluster is doing two things. One, it's recomputing the center of the cluster by basically averaging the x coordinates of the points which are in the cluster. Right, the sum right here is adding together all these points. Right, and so you add together the x coordinates and the y coordinates. And then we're dividing these x coordinates and y coordinates, the sum, by the length. So we're taking an average of the x components and an average of the y components of the points in the cluster, and that's the new center. And then, after we've done that, we reset this collection of points to be the empty set, to be an empty list. In preparation for the next iteration of this clustering method. And then our clustering method, again, points right here is going to be a list of tuples. So the first thing we do is we change those tuples into elements of this point class. We were told to start one cluster, initialize one cluster at the point 1, 0, and the other at the point -1, 0, and so that's what we're doing here. Remember, this A old is a list. It's going to be a collection of points which is in cluster A. This is going to give me a early stopping criteria. All right, I could stop my clustering procedure when this set A old doesn't change from one iteration to the next. All right, each point ends up in, after one step, each point ends up either in cluster A or cluster B. If cluster A doesn't change, well, cluster B doesn't change as well. And then the center won't change, so the next iteration, the clustering won't change, so we could stop. We iterate over this collection of points. We check, is this point closer to the center of cluster A, or is it closer to the center of cluster B? If this point is closer to the center of cluster A, well, stick that point in cluster A. If it's closer to cluster B, stick it in cluster B. And if it's a tie, we've chosen to put that point in cluster B. After checking, after dividing the points into cluster A and cluster B, we check Basically, are we done? If the new set of points in cluster A is the same as the old set of points in cluster A, we're done. And that's what the break will do. This will kick us out of this for loop, this outer for loop right here. We're done. If we haven't finished our clustering procedure, well, now we want to update our set of points in this A old, so we'll be ready to check after the next iteration. Do this step right here before you call the update steps. Why? Because after the update step, A.points is empty. So you want to update this list before you empty out A.points. So update A old, then update your clusters in preparation for the next pass through this for loop. And then here we're just returning this data in the format desired. We probably should just be able to return this, because A starts with a larger X component than cluster B, and that should remain true throughout the clustering process. But, you know, just to be 100% certain, we're just double checking here. We were told to, the return value should be the two centers of the clusters ordered by greatest X value. Return this as a list of numeric tuples. All right, so I have one tuple and a second tuple. And then, you know, as I said, right, we could try this out with some sort of easy-ish results to check that our clustering method is working. Right, you know, basically large values, you know, if I keep the Y values to be, you know, small and so on, and you know, this will be in cluster A, this will be in cluster A, this will be in cluster B, cluster B, cluster B, cluster B. Oh, excuse me, so I could verify, you know, that my results are correct. So, is there anything that's not clear about this clustering method now? Right, so, you know, we're using a few things we have defined for this point class. Namely, we're using the distance method here. We are, when in the in the update method, we are using our add method for the point class, because, you know, this is going to be calling, you know, say this point plus this point, that result plus this point, that result plus this point, etc. So we're using the dunder add method of the point class here when we're computing this sum. I wanted to, in principle, I could define a div method or a true div method, and then I could use that here to define a division if I wanted to between a point and an int or a float. So, as I said yesterday, right, a useful thing that we could do, if I wanted to do so, is that, right, I copied this code into a text file. I added an import here from I added an import here from the math library, and then I added my code for the point class. And then, as I said yesterday, right, this allows me to then use this point class in other code, in other Jupyter notebooks or in other Python code, right? I have a file which I called point.py with a lowercase here in the file name. That's just kind of following a usual Python convention. Then from this file, I could import this point class, and then I could use this just as if I had defined this class in this Jupyter notebook. I could define, I could create instances of this point class. I could, use the add method. I could use the distance method. PT, if I run this code, let's make sure we actually run this. PT1 times PT1 gives me the dot product of the point with itself. I want, 44.2 times this, or whatever. All right, 3 times PT1. Well, all of my definitions for this point class I could use now in this new notebook. If I wanted to, I could, say, copy this code for this cluster into, again, a file, import this class. Right, so writing this kind of code allows me to be able to reuse the code in other settings. Which is, of course, one of the benefits of object-oriented programming. It's kind of modular programming in general. So again, well, once I'm happy with my point class, well, I might save it into another file, and then I'm creating my own library. So what other questions do you guys have for me that I might be able to try and clear up today? I said I'm going to hold off talking about the PW mini project and the DW mini project until we actually get into the data wrangling part of the course. This is only week 3. There are 5 more weeks to go in this course. So yeah, I keep on trying to keep up with your questions that you have online here. Don and I are both looking at your questions and supplying answers to your questions. Apologies once again for the problems with the access to Jupyter Hub. As I said, our provider was having some difficulties yesterday. For some reason, the volumes weren't attaching correctly when pods were being started up, and therefore the pods weren't, basically the pods weren't able to start up correctly. We talked to them, things got sorted out, things seemed to be running correctly, smoothly, for the last, not full day yet, but, certainly the last, 18 hours or so, things seem to be running smoothly. Yeah, we do see your issues when you have them in that regard. If they're not our issues, well, the most we could do is pass them on to our service provider and ask them to fix the problems. But we do try and monitor things and make sure that things are running smoothly. So, as usual, some reminders, you could look at your grades. We keep the highest grade that you have achieved on any of these questions. And then the highest grade you can achieve on any of these questions is a grade of 1. But again, if you get a grade of 1, well, you could go back and experiment. Oh, I want to see, can I get this answer in a different fashion or not? If you get a lower grade, it doesn't matter because we keep your highest grades. And this is true even if if you were to run this update module script to get a fresh copy of notebooks or mini projects, well, that does not affect your grades. So running the update modules script doesn't change your grades at all. You keep whatever grades, you keep whatever highest grade you had before. If you guys don't have questions, I might sit here and do a bit of live coding, talking about what is a generator. So, but yeah, if you do have questions, please feel free to feel free to bring them up in the chat. Generator. A generator is a special type of Python function. So, I mean, this is a slightly advanced topic, but generators are used a lot in Python, sometimes in ways that aren't necessarily obvious, but I'll give you an example with the Fibonacci numbers. Probably seen the Fibonacci numbers a lot here, and you're tired of them, but I'm going to define a function which will be a generator, and this generator will spit out Fibonacci numbers in order starting from the first one. I guess we need to figure out what we mean by the first one. Do we start with 0? Do we start with 1? I tend to think of the Fibonacci numbers starting from 1. So Fn is going to equal Fn minus 1, which is going to be equal to 1. And I'm going to use this yield keyword. Well, let me actually write a easier generator. Here is a generator. It uses the yield keyword. I can actually even make this simpler, sorry. All right. Sorry, live coding, always fun. Touch on how generator comprehensions work. Yeah, I think so. So here is a simple generator. I'm using the yield keyword here instead of return. And yeah, I could talk about reduce filter and map, yes. Let me demonstrate the use of this generator right here. So I've defined a function, something that looks like a function, the def keyword, but I'm using the yield keyword instead of return. a way that I could use this is I could define a variable which will be equal to, you know, this function call. And then I want to use this next method right here. I say next counter. If I say next counter again, I get 2. If I say next counter, I get 3. If I get next counter 4. What's going on is that this right here creates an instance of this generator. The next method right here says, all right, I want to run this generator. So when this generator starts, this variable counter is set to 1. We have this while loop, which, while true, so this is in effect like an infinite loop. This yield method right here, yield acts like return in that you will get a value out. So yield counter, and counter begins with a value of 1, and that value of 1 is spit back. And this generator stops. When next counter is invoked, this function picks up where it left off last time, right? The last line of code that was run was this yield line of code. This method picks up on the next line. So it will increment the counter. It will return into this while loop, while true. True says, yeah, keep going. And then it will yield this counter again, and you'll get the value 2. And then this generator stops. When next is run again, well, again, this generator picks up at the very next line of code where it left off previously. It increments the counter, goes back up to the while loop, yields the counter, and stops. And this is what I mean by a persistence of memory. This value of this counter internally in this generator is remembered in between calls using the next method. I could have a few of these things, you know, going at the same time. I could say, here's an other counter. I could create a new instance of this generator. If I call next on my other counter, I get 1. If I call next on my counter, I get 5. Right, so I could have different instances of this generator going at the same time. If I call next again on my other counter, well, I get 2. If I call next on my other counter, I get 6. Now, you might say, well, how are these useful? Why are these useful? Well, again, one of the main uses is this sort of persistence of memory. This variable, which is internal to this generator, is remembered between invocations to this generator. Right? And of course, as I said, I can have more than one instance of this generator going at the same time. A lot of the tools in the iter_tools library are implemented as Python generators. One of the benefits of the tools that are in the iter_tools library is that they're designed to work without using a lot of memory in your computer. If you haven't looked at the itertools library, itertools Python, I don't know why my computer's taking so long to finish this search. So itertools Python gives me, this first link right here. This is I'll post the link into the chat. As I said, functions creating iterators for efficient looping. So this module standardizes a core set of fast, memory-efficient tools that are useful by themselves or in combination with each other. This actually implements its own count iterator. Which is nearly like the one that I wrote, but this one allows for you to specify any starting point and any step size. And these are infinite iterators in a sense that, yes, in theory, they just keep on going as long as you want to use them. There's things like accumulate gives partial sums. Some of the more useful ones I've used a lot are things like product and permutations and combinations. As I said, part of the point of this library is they are memory efficient. They're not using a lot of memory. So this permutations can generate all of the, as it said here, R-length tuples, all possible orderings, no repeated elements. But it generates them one at a time. It does not create a big long list of them and then feed you elements from that list. It gives you these elements one at a time. And as I said, these are basically all, implemented as generators. They do give you, something like is roughly equivalent to this kind of code, but it's not really, written using this code. You can see, accumulate roughly equivalent to this code. You can see inside here you have a yield. You have a yield. Chain, all right, yield. So again, these are all implemented as generators. So this gives us memory efficient tools. We often use these kinds of things in, in for loops. I could write Fibonacci, I can write a generator which will return the Fibonacci numbers while true. I can move my yield down into the while true. yield fn, and then I will say fn fn minus 1 is equal to fn plus fn minus 1 comma fn. Here's my Fibonacci generator. Fib is Fibonacci for I in range 10. Print next fib. And I get the Fibonacci numbers. All right, I might, to get the sequence I'm normally used to seeing, I might do this. So I get 1, 1, 2, 3, 5, 8, 13, 21, right? One term is the sum of the previous two. If I run this again, this will continue giving me the Fibonacci numbers larger values. If I run this again, etc. If I want to restart, well, I can just rerun this code and recreate my generator, and I start from the beginning. All right, so again, it's the yield statement which turns this into a generator. You know, I might use this to say for I in enumerate Fibonacci for I and F. This gives me tuples. Print, let's say I and F. I need to terminate this for loop, otherwise I'll have an infinite loop. If I equals 10, break. Right, if I remove this if statement right here, I have a infinite loop, which I will have to break out of by interrupting the kernel. I said by interrupting the kernel. Well, I basically filled up the memory before I did that, so be careful. All right, you could create infinite loops. Keyboard interrupt here. All right. You know, if I have an infinite generator, I want to make sure that I will stop it in some way, or I use it appropriately. So again, if I is now 100, break. And I basically had to, you know, rewrite. All right, so I need some way again of breaking out of this infinite loop, because this Fibonacci generator right here will in principle just keep on going forever. Every time I call, I iterate, this is like implicitly calling next on this generator for me. I don't have to do it. These numbers get large soon. So this is what generators they are. They use the yield keyword instead of return. A lot of things are implemented in Python as generators. So questions about map. The map method is available without having to import anything. Map lets me apply a function of a single variable to some iterable. And the map itself is a generator. I could get some output by wrapping the map function inside list. I usually don't want to do this if I don't have to. I don't want to do this if I'm mapping, applying the map to a large iterable. I don't want to just wrap list around it arbitrarily. So again, a map is a generator. So this is implemented in a way that that if I wanted to, I could iterate over the map, and I would get one element at a time. For I in map lambda x squared range 1 to 11. Right, this would return one element at a time. I'm printing out these numbers, as you can see here. So the idea of the map is going to apply a function of one variable to some iterable and give me a new iterable. Usually, but not always, usually this function is defined using a lambda function. But Python is perfectly happy f of x return 3 times x squared minus 2x plus 10. Python is perfectly happy, plus 10, not equals 10. Python is perfectly happy to apply, so map f on range of 1 to 11. And again, for the purposes of demonstration, I'll map list around this. 3, if I get my function definition correct. Right, this is a function of a single variable. So Python will apply this function f on this iterable and give me a new iterable. So while we might usually specify these functions with a lambda function, I could give Python a function that I have defined that takes one parameter. In fact, this function here, it doesn't have to return a single value. It could return, I don't know, it could return a tuple. Return this tuple of values. And this will, take a single value and return a tuple. And again, single value, well, I could define a function that would take a tuple and just treat it as a tuple and map appropriately. Right, so, when I say single value, I don't necessarily mean single number. The value itself could be a tuple, and then I could just extract things from the tuple inside. But yeah, the map function, so again, it's designed to apply a function to an iterable and returns a new iterable with those function values. right? So I don't have to write a for loop to apply this map to every element of this iterable. I could just call the map method, and it will do that for me. And I'll just mention the filter method. The filter method is also available without any imports. So it returns an iterator yielding those items of iterable for which the function item value is true. So I could, for example, I could say filter, again, usually we write a lambda function, lambda x mod 2 is equal to 1, is equal to 0, range 1 to 11. And again, the filter is implemented as a generator, as an iterator. Right, so I'm going to get all the values from this iterable where this function evaluates to true. All right, so x %2, remember percent is remainder. I want to take these numbers, these integers, divide by 2 and find the remainder. And I want to say, is that remainder equal to 0? So what is this doing? It's filtering to keep all of the even numbers in the input. If I were to change this to 1, well, I get all the odd numbers. If I change the 2 to, let's say I put this back to 0 and I change this 2 to 3, x %3 is 0. What? This is all the numbers which are evenly divisible by 3. So the remainder, when divided by 3, is 0, so all the numbers are evenly divisible by 3. Or, you know, x %3 is 1, all the ones whose remainder when I divide by 3 is 1. Right, so filter, again, I apply a function to some iterable. It doesn't have to be a range, it could be a list, it could be a collection of keys from a dictionary, some other iterable, some, you know, right? But I apply a function to an iterable and I keep the values where this function evaluates to true. So whatever that function you want it to be. And again, I don't have to use a lambda function. I could write a function, you know, with a def keyword and on this iterable. So again, filter, I apply a function to an iterable. We keep all of those values where the function evaluates to true. And again, I don't have to write a for loop. The filter is doing that for me. I'm nearly out of time, but if you remind me on Monday, I could talk about the reduce function, which we do have to import from another library. So reduce, this basically takes an iterable and will apply a binary function to reduce this iterable down to a single result. But I'll need to talk about that on Monday as we're out of time here. So I'll wish you all a pleasant weekend. More videos will be made available soon. Have a good weekend. I'll see you on Monday. Be safe, be well, and be good to other people.